Hi, everybody. Thank you for joining us today. My name is Lisa Travers. I'm with Alliance Corporation, and I have as well Tom Ferris from Alliance and Mark Madden with RAD. I'm going to hand things over to Tom. He's going to do a really quick introduction to the company. Just one or two housekeeping notes. One, we do have everybody on mute for the presentation. If you want to ask a question, you can just put it in through the GoToWebinar chat console. And then we are recording the presentation, so afterwards we'll send out a link to the YouTube video. As well, when I send that out, if you want a copy of the presentation, just send me a quick note and I'll send you that as well. I think that's it. I'm going to hand it over to Tom. Thank you for joining us. Tom?
Thank you, Lisa. Thank you very much. Welcome, everybody. Appreciate you all coming on board today. My name is Tom Ferris. I'm the Director of Sales here at Alliance Communications. I manage the USA broadband operations. Broadband meaning literally anything you plug into a wall. So it could be a radio, it could be a power system, it could be a distributed antenna system, as well as all the other products and services that we provide here. So what I'm going to do, like Lisa said, I'm going to give you a brief on Alliance Communications, who we are, what we do, give you some of my thoughts about the session today, some of the things that I think are we're going to highlight here and the things that excite me, and then I'm going to turn it over to Mark. And we'll be about, we'll be probably a little bit less than an hour today, so we'll try to all get you out of here by 3 o'clock. All right, again, appreciate you coming on board. So what's exciting about today's presentation? There's a picture here. I'm a New Yorker. I live just outside of Manhattan, and I've been through a couple of blackouts in my 57 years, and this was one of them, the last one we had in New York. And you see, New York is pretty dark right here. These are some of the things that I'm sure a lot of the folks on the call here today who are part of the utility vertical market, this is probably your worst nightmare, right? So, and the reason for outages like this can be of a variety of things. The one thing we do want to always try to protect against is the cyber threats from the outside, because those seem to be the most menacing. Those are the ones we can't control potentially by putting in repaired infrastructure and whatnot. So what we're here to talk about today, and what's exciting, is the company RAD Communications, who we are a distributor for, has been working for several years now developing a suite of products that address the cybersecurity aspects of for protecting not only utility-based networks, but all IP-based networks. And you're going to see some interesting concepts and products today from Mark. But again, I think it's really vital, obviously, to secure the critical infrastructure that we have, especially here in the United States, being a U.S. citizen. More and more of the remote devices that are being deployed in utility-based networks, in agriculture-based networks, in mining networks, in all critical infrastructure networks, are IP-based. We're getting away from the days of serially connected devices, and we're getting into these smarter devices that are all residing on our networks. The networks are getting more complicated, and they're probably getting a lot harder to control, to manage, as well as to secure. So hopefully you'll see some things today that kind of put some light bulbs on over your head, and hopefully potentially take care of some of the issues that you may be anticipating or even experiencing today. The other thing is, we're getting into this Internet of Things world where, we're going to be putting IP connectivity onto everything from network devices all the way down to our toasters and refrigerators at home. Now, obviously, I don't want somebody hacking into my home, turning my lights on and off on me all night and whatnot either. So, as a citizen and somebody who embraces technology and wants to see some of this stuff coming on board, I want to make sure it's secure. I want to make sure that the companies out there that are offering me these services are protecting my interests as well. So I'm interested to hear what RAD has to say as well today. And the last thing that's kind of exciting is, as a distributor, we take painstaking, we have painstaking methods to try to evaluate the products that we sell. We do not put products out there that do not match the environments in which they go into. And the nice thing about the RAD products is they are industrial grade products. They can sit inside of any hostile network environment out there, and I think you'll see evidence of that today on our call. Okay, so just getting into a little bit about Alliance. As I said earlier, we are a distribution company. We provide a variety of different products, both wireless and wireline, which includes any type of radio that operates from the 200 megabits, 200 megahertz band all the way up to 80 gigahertz band and everything in between. We also carry a full line of wireline products, so any of the Category 5 coaxial or fiber-based products that are required, not only in wireless networks, but also wireline networks, we provide product for. In addition, what's hot these days is IDAS, indoor and outdoor distributed antenna systems. This is to be able to provide ubiquitous cellular coverage for both public use as well as public safety use throughout any type of building infrastructure out there. And then on the top right-hand corner, you'll see something called infrastructure. Basically what that is, it's all the steel, the cable, all those static devices that go into the implementation of any type of wireless and wireline network. And then the last piece is supply chain services. So I noticed we have a lot of utilities on the call today. You folks, when you do things, you usually do things in a big way. Your rollouts take many, many months and require many, many different parts. We have warehouses throughout the Americas whereby we can put the infrastructure, the products that are required for multi-month or multi-year rollouts into our buildings for you. We can do staging, we can do all types of other types of services that may be of value to you. So we welcome any calls after, any requests from you after the webinar today to get into a little bit more detail about what you're up to and what we can do for you. Again, as we are a leading supplier of infrastructure solutions, we're probably one of the best kept secrets out there. We have a wide breadth and scope of products. Everything here is world class. You're not going to see any junk and garbage that somebody can go up on Amazon and go buy. We sell good stuff. We sell stuff that goes into industrial environments, and we match the products to our customer requirements. We provide personalized and expert assistance. Pretty much everybody on my sales team has been in the industry for more than 10 plus years. So we don't always have to bring in vendors when you're asking us questions. We make independent recommendations as well. We have a lot of overlap in our products, so we can be an honest broker when it comes to technology choices. We provide a variety of different pre and post sales technical support, as well as on-site manufacturer training programs. And as I said earlier, we have warehouses throughout the United States, Canada, and Latin America. These are some of the technical services we provide. So when you're building out networks, there's a lot of different pieces of a network. Microwave radio is a big seller for us. So we actually provide microwave path licensing as well as path planning services, and these are generally free of charge. We'll also design your networks. We'll do the path surveys. We'll also do product pre-configuration in our warehouses. So if you want a product to show up, you can basically just grab and go out to site and install it. We can configure these products before they ship from our facilities. We do kitting as well. So kitting can mean a variety of different things. We can rack and stack pre-built cabinets, or we can kit the entire product list of a particular site onto a pallet for you, shrink wrap it, and send them out to your locations. We're also in the steel and tower business, and we know how to design towers as well. So if you need any infrastructure to support any of the outdoor RF equipment, we can help you by designing the towers and recommending a variety of different manufacturers. And then we also provide tier 1 and 2 technical support and RMA support for many of our products. And this is kind of just a quick look at some of our premium products that we sell today. These are all active RF companies, and there's a combination of point-to-point, point-to-multi-point, unlicensed, licensed systems, Wi-Fi-based systems, as well as LTE-based systems, plus a couple of power companies down there below to offer a complete line of AC, DC, and renewable type power products. And that's it from my side. As Lisa said earlier, we're recording today's session, and this will be up on our YouTube channel. So if you have to skip out a little bit, or you have any friends out there who couldn't make it today and want to see this, you can refer them to our channel. And if you want to go up on any of these social media sites and join our Facebook sites or our Twitter feeds or whatnot, please feel free to go up there and take a look at us. Lisa will be sending out this presentation to everybody on the call after the session's over today. Again, thank you. I'd like to turn it over to Mark Madden, the VP of Critical Infrastructure at RAD. It's all yours, Mark.
Thanks, Tom, and thanks, Lisa. I appreciate the opportunity to come and talk today. I'm going to talk a little bit, obviously, on cybersecurity. It says for SCADA systems, but it's really for industrial control systems in general. So you can look at any of the things I'm going to talk to about today and realize, even though I might use a utility example, there is application across smart cities, various other critical infrastructure requirements. Because ultimately, it's about keeping things tied down so you are able to deliver the service and the reliability you're expecting to be able to do. I do lead the North American line of business for critical infrastructure and RAD. It's something I've myself only been doing since about March, coming from another large telecommunications manufacturer. I have had the opportunity, now that I'm here, to realize the depth and breadth of RAD's portfolio in this space, and I'm here to tell you that it is very impressive. It is everything from microwave systems all the way through to edge devices and core networking elements. There's a lot of different things that could come into play across a wide variety of technologies, and RAD is pretty uniquely, and there's only one or two other companies that can address the entirety of a solution across the space. RAD has been in business for 36 years. It's a multinational, for those of you that don't know it well, it's a multinational conglomerate. Our US and North American headquarters are here in Mahwah, New Jersey. And so most everything we're going to do and talk about in North America is available through our North American headquarters. Let's see if I can get the show to work. There we go. So as Tom was suggesting, we're seeing this migration from SDH, or actually TDM in general. It doesn't have to be Sonnet, but TDM in general, moving everybody, whether they want to or not, out of a TDM environment and into a packet switched environment, whether they're using a variety of technologies, which could include carrier Ethernet or some flavor of MPLS, or just straight IP. There's a lot of new IP-based and layer 2 Ethernet services that are being adopted in order to bring additional capability as well as deal with some issues such as the carriers sunsetting leased lines, turning leased lines down, the traditional services that everybody was counting on, but also equipment obsolescence. This has been going on for a long time. This equipment obsolescence, there's a number of manufacturers now that are no longer in the business, and support for those services is going away. So, like I said, you're being forced to move one way or the other. We also have additional interest in providing services across municipalities, so things such as smart grids and smart cities all require much more communications capability than existed in the past. But this also does lead to a conundrum, because in the past with the TDM technologies, you either had to have direct access to the line, in other words, be able to tap into the line, or alternately, it was riding on obscure protocols that were difficult to decipher for the average person. With moving to Ethernet and IP-based services, we have a set of technologies that are much more well-known, and much more well-known by people who we would prefer didn't have access. That's the bad news. The good news is we do know a lot about how to protect these systems, whereas before we had some security by obscurity, we also didn't really know where our exposures were. In the case of packet switch technologies, such as IP, such as Ethernet, we actually do have some understanding of where our exposures are, and a lot of tools available to help us protect it. This is a RAD because of the movement towards IoT or smart grid, continuing to evolve the utilities. This is a rather impressively growing market. There's a great deal of demand. And, you know, we see, at least RAD does, that our markets are growing for these kind of systems at over 10% per year. So this is where everybody is headed, and this is how we're trying to protect things. So for those of you on the phone that are working for a utility or a municipality, one of your challenges is trying to maintain those legacy services that you have while trying to figure out how to migrate at the same time. And this is something we specialize in because we are able to connect to both the TDM and the packet switch technologies at the same time and handle them both natively. And we're providing a smooth migration path that you can utilize for these new IP-based services. Also with security built in. And this is an important thing because you need to establish that security defense as you're building these new systems out. Because once you're exposed, once somebody's in the door, they may be there for years and you'll never know it. So, you know, being able to maintain that robust cybersecurity defense is a critical piece of what you need to do. Compliance with security regulations, or if you're a U.S. utility with transmission system assets, obviously you're subject to the Critical Infrastructure Program version 5, CS635 from NERC. But even if you're not, you're a Canadian utility, NERC, the NERC SIP rules give you a good foundation for the things you should be doing in order to protect yourself. So we'll show you a little bit about that today. But also everything that RAD is working with here in North America is all required to be hardened and built for difficult and sometimes hazardous environments. So, you know, compliance with IEEE 1613 environmentals to include, you know, broad temperature ranges and EMI interference are critical to the solutions that we are bringing forward into the space. And I was talking a bit about building in cybersecurity, and what does that really mean? From a communications vendor, it means a few things. It's not the entirety of everything you need to do as a company in order to protect yourself. A lot of that is policy and procedure and establishing rules and limitations on authorities. There's all kinds of things that are in there. But when you're a device manufacturer with communications gear, there's really 4 things that we can do to help you, that we can build into the equipment to allow you to deal with that. You know, so those are services such as device connection control. That's, you know, making sure that somebody can't just plug a device in and then have access. That's the how do you keep somebody from just breaking in with it when they've got physical access. That might be 802.1x. There are some other technologies out there that can be used for that, but that's the most common. To keep all the ports turned off on or at least set off by default so somebody doesn't make a configuration error, and allow for openings in the network once they have physical access. A second thing related to access control is about intermediate system authentication. So that's where you're not relying on the end device to protect itself, but rather you have some centralized control of user privileges and rights and users and systems that can mediate who can have access and when they can have it. So the purpose of that is to challenge and accept authentication and assign those rights, and it could be down to a single device they're allowed to get to, or it could be a range of devices, or it could be down to, can I do this kind of function in that device or that kind of function? And so managing that authentication of services and availability of service to each individual user is a key piece of this. Being able to detect malicious communications, something we'll commonly call intrusion detection or intrusion prevention, anomaly detection. We look to be able to look at the characteristics of the application, the kind of communication the application is natively sending itself versus what somebody else could insert. So is this a packet that makes any sense? If I'm sending a SCADA command, is this a valid SCADA command, or is somebody attempting to confuse the system or try and put it into a situation, into a range that's not a valid range? A lot of denial of service attacks or security attacks are about sending packets that cause the system to have to think about what it's doing before it reacts. So is that a valid SCADA command? SCADA commands are kind of this kind of thing where it's almost machine language. To put this value in this register. Is that register a valid register? Is that a valid value for that register? So being able to have an application of SCADA where firewall is also a really significant piece of managing that and then alarming on it. So can you tell when somebody's done that? And the answer is you need to. So that you can take actions that will prevent them from doing further damage. And then with man-in-the-middle attack prevention, this is where we do site-to-site, preferably end device to end device encryption of data. Can I spoof this network or not? And if the answer is no, then it's encrypted. I can't read it. The device or the security protocol recognizes that somebody's tampered with a packet or that's not a valid end device to be talking to me. Then I can prevent that man-in-the-middle attack from occurring, even if they have physical access to the equipment. So these are key pieces of building in cybersecurity in a communications infrastructure. Obviously, there's many more than that, and they might be application specific. They could be, and of course, constant monitoring and testing of network and application vulnerabilities is key to this, as well as just making sure that the people you have working for you are not out to do you harm, whether intentional or otherwise. So that said, let me tell you what RAD can actually do in this space, because obviously I can't address the full range of things that need to be done for cybersecurity. But regarding solutions, we have several things in our toolbox that allow us to build very secure networks. When we start talking about edge level security, those are the devices that are out in the field. It might be a recloser sitting on a pole somewhere in the middle of the field. It could be a wind turbine. It could be a substation itself. Even though it's relatively secure, when you look at it from the outside, when you come to realize it's seldom protected by much more than a fence and a chain and a padlock, the opportunity to get in there is obviously high. So we have a number of devices that we use in our solutions. Our SecFlow products are designed specifically for harsh environments. They're fanless. They're built to IEEE 1613 specifications for environmentals. That's minus 40 degrees Celsius to plus 70 Celsius, very, very wide temperature range. We have the ability to be able to provide virtual private networks with these devices. We can connect Ethernet and serial lines to these devices. We can use a variety of different technologies for backhaul, which include fiber optic or copper-based networks and also cellular networks. So within the device itself is an internal stateful firewall. This is actually a fairly intelligent little box. It's fundamentally it's Linux running on an ARM processor with specialized communications hardware to manage the interfaces themselves and provide things like pseudowire. They have routing engine in them, so we were able to do IP routing with it and set up layer 3 VPNs using IPsec or as a secure encryption mechanism. Also VRFs, so virtual routing functionality. So we can completely averting virtual routing instances. We can set up to 4 different virtual routers on the box, completely isolating even the address space. We're very closely aligned with several different firewall manufacturers that provide SCADA-aware firewalls, and those include Cisco and Fortinet and Checkpoint. And with those, we've established a way to automate the PKI, public key infrastructure approach, meaning that every device or every link has its own key as opposed to using a pre-shared key, where everybody uses the same key. Now we can automate that PKI so we can use unique keys for every device and incorporate X.509 certificate authorities that allow us to very precisely control the encryption and the access to the device or shut it off as needed. But one of the key challenges around that was being able to manage all those keys. So, using simple certificate enrollment protocol, we're able to provide an automated approach to managing that key infrastructure, which would otherwise be very difficult to do in a high density environment. Included in the device is an internal stateful firewall. I mentioned the routing engine. We do pseudowire over it. We do cellular networks over it. So, and then we have it set up so that we can do zero-touch deployment. So when we talk about zero touch, as the device comes online, you don't need to be an IP wizard to turn it on. You can send a field technician out with it. He can install it, turn it on. The device will come back automatically and say, "Who am I?" and get all of its configuration information and come up without somebody having to actually touch it, which substantially reduces the deployment issues associated with putting things out. In addition to that, we also use this device to provide power over Ethernet, so to other devices. So if you were to hook cameras to it or radios to it, we can power those devices using the systems in a variety of different configurations, network configurations. So whether it's over lease services or through an ISP or your own private network or cellular network or fiber or copper networks. This is the point being is a very flexible device in terms of how you bring it up and turn it on. The other piece of our security portfolio relies on a technology called network function virtualization. Network function virtualization essentially means that things that would have been appliances in the past, such as a router or a firewall appliance, can be reduced to a software application and then put onto a standardized server platform and then run off of lower cost or easier to manage commercial hardware. What we have done is we've taken and shrunken, is that a word? Shrunken that server and put it down into what is essentially a blade that fits into our Megaplex line of products. So this is an x86 server, Intel-based server, that is able to provide that function, again, firewall, protocol conversion, terminal server, router, whatever it is, within the envelope of the Megaplex. And I have a number of customers that are deploying Checkpoint and FortiGate firewalls in all of their substations. And this is a way to do that without having to put another dedicated appliance, save rack space and power, and have direct access to all the interfaces that are in there. So yet another approach to this, a way to localize the firewall. If you need that application, you need the high density or higher bandwidth firewall available than you might otherwise get, then we can put that into our device. So, but I kind of hinted at, we've done some more work than that, in that one of the things, we're trying to deploy a firewall in every single branch office or substation becomes expensive. If nothing else, just for the licensing fees associated with the firewall itself, particularly when you're trying to do intrusion detection on an application-aware firewall. Substation licensing costs get to be quite high, particularly if you have a lot of substations. So what we've done is we've taken our SecFlow SecFlow switch, ruggedized switch, and we've integrated it quite closely with Checkpoint and Fortinet software. We're also compatible with Cisco ASA, Cisco PIX, and a few others, most major firewalls. And we are able to utilize a standard centralized firewall, whether that's sitting in a Megaplex or it's sitting on a native appliance, a firewall appliance, and extend all those policies and procedures and user authentication and all of that, provide the intermediate system by just integrating that with our SecFlow. So the SecFlow gets a request for traffic, and immediately goes, I don't know who you are. It sends you back to the, I mean, if you try and get into it that way, you have to go back to the firewall and authenticate against the firewall. The firewall then, if it decides you're okay and you're actually able to get to that device for that specific set of commands, it will then forward that request back to the security gateway, which in our case is the SecFlow firewall, which will then allow you to talk to whatever that device is, whether it's an RTU or some intelligent electronic device. And it does that with both the data and the management plane. So we can take the serial management interface and plug that into the SecFlow, so that if you're needing to get to that management interface, you still have that intermediate system authentication available in order to validate the user and the system that's trying to access it. In addition, of course, obviously, we are using the data plane itself, whether that's Ethernet or serial, and managing that in much the same way. In this case, though, we're actually looking at the data, and now here's where our SCADA-aware firewall comes in. Is that a valid SCADA command? Is it trying to be sent out or sent back into it? And, you know, is somebody gotten in there and done something bad, or is this a normal application activity? And that is also done up against that authentication with the firewall application. Again, whether that's Megaplex with the NFV card and a firewall software on it, or it's some sort of secured multi-service platform or third-party appliance that you're using for that system. So it brings all of the malicious communication detection, the intermediate system authentication, all those things we talked about on the previous page. Oh, and the encryption, end-to-end encryption, and brings those all to bear into a single solution. One of the things that was hard to do about this is we were able to do this now over cellular connections. And the reason why that was hard to do and required some work is that cellular connections cannot guarantee you an IP address. An IPsec does not behave well when the IP address is not known or changes. In fact, it won't work because it's bound to those IP addresses. So one of the things we were able to do is do some fairly close integration with the firewall manufacturers to find a way to provide that same IPsec tunnel over a cellular connection where the address might vary, and frankly will vary. So we've established that. We have that working so that we can use cellular networks as our backup link, as a failover link, and still maintain the security over it. Or we can, you know, on low value assets, we might use that as the primary connection. So again, providing that same level of security across those systems. The typical applications that we see for this has been around a number of things. It's usually around distribution automation. New devices are going out, whether that's a recloser or some sort of line sensor or a thing that might not be contained within the substation. It could also be inside a substation. We see that as well across a variety of interfaces. So, you know, whether it's going across somebody's leased fiber optics or the cellular network or your own private network, we can reach out and provide smart metering backhaul, encrypted smart metering backhaul. And I do have utilities that are insisting on encrypting the traffic all the way from the meter back to the meter head end. And so we can isolate those devices. We can put this in front of a cybersecurity perimeter, which is required under SIP rules for anybody participating in the bulk electric system that allows us to protect those assets and segregate them, encrypt them and segregate them so that they are not visible to any other application you might have on that network. In other words, segregating the meter traffic from the SCADA traffic, from the teleprotection traffic, from the whatever it is, and across a variety of interfaces. You'll notice I have our earmux line down at the bottom here, and as I mentioned before, with the power over Ethernet, what we do in these applications, particularly for utilities, is we subtend the radio off of the SecFlow. The SecFlow then provides all the end-to-end encryption and security through that radio network, but it's also providing the power for the radio so that we're minimizing the number of boxes that are available or required to do that. Another thing we see, pardon me, is devices that are spread around out in the field. So whether or not you're trying to talk to or using a SCADA radio or a mass radio of some kind to talk to distributed assets on poles, or you're using another technology, we can put the SecFlow in a small cabinet at the bottom and provide that network layer of connectivity and encryption back into the rest of the system, whether that's for things like fault indicators or reclosers or transfer trips devices or whatever that happens to be on poles. We have some people using it for capacitor bank connectivity. So be able to get to, I have one utility that's actually deploying it, and they are deploying strategically in automatic teller machines for people to be able to pay their power bill through an ATM. And these are dedicated to that utility. They are, so they're putting a SecFlow in each and every one of those so that they have that encrypted communication back, and they're protecting the financial aspects of themselves and their customers. Lots of different applications, particularly in the utility sector for this. we even see this in terms of water management. So, being able to provide that encryption and protected communications to do things like water flow management or pump life cycle or a variety of different maintenance applications, monitoring well water levels, monitoring sewer lines, sewer pumping stations. Those are the kinds of applications we see that still need to be protected. There was a water authority in upstate New York, I believe it was upstate New York, that was subject to some cyber hacking, and somebody figured out how to control the dam because they were able to get into the dam. And this is another area where we could have prevented them from doing that by just implementing the edge level security that's available with the SecFlow. So key benefits and features of what we're looking at here. Our products are designed for harsh environmental environments. The SecFlows are DIN rail mount. The Megaplexes are cabinet-based, but the SecFlow is an IP30 design by nature, but it can go into an IP67 cabinet, which allows for waterproofing and a wider range of environmentals. They're EMI immune, so they fit well into substation environments with a high degree of electromagnetic activity. We have designed them specifically for compliance with IEC 61850-3, which is an environmental spec, and IEEE 1613, which is its US equivalent. Around security, we've automated PKI. We provide OSI level 2, 3, and 4 access control lists so you can determine a range of IPs that can get in there. We do MAC and IP filtering per port. This is native to the box. We do layer 2 and layer 3 VPNs with IPsec, 802.1x, and radius attack-X for security of management of the box. The extra sauce on that is the ability to incorporate that SCADA aware firewall, which isn't native to the SecFlow, or the Megaplex, but is easily added to it. So this is one of the key things that we're doing, and that it's that integration with the best of the breed in the firewall world, with the best of the breed in the communications world. In terms of functionality, the Megaplex has every low-speed interface known to man in it. A bit of a joke, but it's our Swiss Army knife, so it's a great deal, and it can function as a TDM environment or SONET environment or an IP environment. You can do MPLS, the appropriate router network function added to the x86 cards. We can do Ethernet OANM, static routing, OSPF2. We just recently added BGP to the SecFlow, so it could be used. Not sure I would do it, but it could be used as an edge-to-edge routing device, one network to the next. With virtual router redundancy protocols, they can participate in switched Ethernet rings, so it's got the G8032 ring protection built in. And we can tie it up with cellular connectivity. We talked a little bit about this being a multi-service device. It comes natively with both Ethernet and serial ports built into it, so it can operate doing pseudo-wire over Ethernet. It can in either direction. We're able to use both the Ethernet ports and serial interfaces simultaneously. We can do serial tunneling. It'll act as a terminal server, as a secured terminal server, and do the necessary SCADA protocol conversion going from the old IEC 101 to IEC 104 or MODBUS and DNP. So it handles all of those protocols. It understands them and is able to provide whatever necessary translation it is to get to one to the other. So some of the protocol conversion can be done by the box as well. So, as a key takeaway, we believe this is a perfect solution for a secured wide area network, automation, backhaul, what have you. As an edge level device, it is key to providing that edge to end-to-end security. With Cyber Shield, with some of the native capabilities that are in the box and boxes. Our differentiators is these are highly integrated devices and solutions. We do have advanced routing capabilities in all of them, so we can support a variety of IP devices. We have a great deal of interoperability with a variety of secured firewall appliances. And we're doing PKI, and we're doing it in an automated fashion, so you're not having to kill yourself with trying to manage tens of thousands of keys. The SCEP server can handle that for you. And that comes to the end of my presentation. I thought I'd check to see if we got any questions out there.
No, I don't. Sorry, I had to unmute myself. No, I don't have any questions. I don't know if anyone wants to submit any right now, but at the moment, I don't have any. Maybe I'll just hand this over to Tom. And if anything comes up, we'll, if you just stay on muted, Mark, we'll ask you.
All right, thanks. Thank you, Lisa. Thanks, everybody. Looking at the screen here, it looks like most of you folks stayed with us the whole time. Really appreciate that. A lot of information today. Mark obviously knows this stuff. RAD obviously has a good handle on the types of requirements out there that hopefully some of you need assistance with. And you're going to probably hear from us in the next day or two with a follow-up. Please reply back if we can be of service to you. You might also hear from a salesperson. So, let us know what we can do for you. And if there's anything else you saw on my slides today that interests you at Alliance, please feel free to send us a note as well. All right. Again, thanks, everybody. Keep an eye out for the emails, and we hope to see you on another session soon. Thanks. Lisa, anything come in, or are we?
No, I haven't had any questions. So just as an aside, if anyone does have any, you can always send them by email afterwards, and I'll forward it to Mark, and he can get back to us that way. Thank you, Mark, and thank you, everybody, for attending. And like I said, I will be sending out a copy of the presentation, the webinar link, and if you want a copy of the actual PDF of the presentation, just send me a quick note. Have a great day.